This is a math teaching video made by Jasmine, Riley, and Grace. Today, our topic is conic curve. Chapter 1, Conic curve, ellipse.
Basic knowledge concept. First of all, two definitions of ellipse. The sum of the distance between the two fixed points f1, f2, and the fixed length 2a greater than the absolute value of f1, f2. Set point M equals absolute value of p f1 plus absolute value of p f2 equals 2a. 2a greater than the absolute value of f1, f2. When the 2a equals the absolute value of f1, f2, f1, f2 is a line segment. When the 2a less than the absolute value of f1, f2, no trajectory. The 2 points f1, f2 for the focus, the distance between the fixed point called focal length. The second definition of ellipse. The ratio of a point in a plane to a fixed point and a straight line is a constant of the point of the normal number less than 1. That is, the constant of the point set M equals P, C over A equals E, 0 greater than E greater than 1. E greater than 1 for parabolic, E less than 1 for hyperbolic. Standard equation. The first one is the focus on the x-axis, the center at the origin. A greater than B greater than 0. Focus f1 is negative c0, f2 is c0. X squared over a squared plus y squared over b squared equals 1. Second equation is about the focus on the y-axis, the center at the origin. A greater than B greater than 0. Focus f1 is 0 negative c, f2 is 0 c. Y squared over a squared plus x squared over b squared equals 1. Attention! In two standard equations, there are always a greater than b greater than 0. C equals the square root of a squared minus b squared. The focus of the ellipse is always on the long axis. And then, the two standard equations can be expressed in the general form. Ax squared plus by squared equals 1, a greater than 0, b greater than 0. And a does not equals b. When a less than b is the focus of the ellipse on the x-axis. A greater than b, the focus is on the y-axis. For the focus on the x-axis, the center is at the origin. Has the following properties. A. The nature of the coordinate system. Number 1. Range. The absolute value of x less than or equal to a. The absolute value of y less than or equal to b. Number 2. Symmetry. Symmetry axis equations is x equal to 0, y equal to 0. Symmetric center is O, 0, 0. Number 3. A1 is negative A0, A2 is A0, B1 is 0 negative B, B2 is 0B. Long axis, the length of A1, A2 equal to 2A. Short axis, the length of B1, B2 equal to 2B. Semi-long axis length is A. Semi-short axis length is B. Number 4. The line equation. X equal to positive or negative a squared over c, or y equal to positive or negative a squared over c. Number 5. The maximum length of PF equal to a plus c. The minimum length of PF equal to a minus c. Number 6. Eccentricity. E equal to c over a, focal length and the long axis length ratio belong to 0 to 1. The greater E, the more flat. E equal to 0 is round. Number 7. Focus distance equal to b squared over c. Line spacing equal to 2a squared over c. Number 8. Two largest angles. The maximum of angle F1P F2 equal to angle F1B2 F2. The maximum angle A1P A2 equal to angle A1B2 A2. Focus on the y-axis center at the origin is similar. Special attention. Elliptic equations in A, B, C, E and coordinate system has nothing to do. And the focus coordinate, the line equation, vertex coordinates, and the coordinate system. Therefore, it is necessary to determine the elliptic equation 3 conditions. Two shaping conditions, A, B, a position condition of the focal coordinates or the line equation.
Hi, this is Chris. Welcome to the classwork time. Here's our first question. The center of the ellipse C is known as the coordinate origin. And the two focal points of the ellipse are -40 and 40. And C pass through the points 5, 0. The equation of the ellipse is... From the question, we can easily know that C equals 4 and A equals 5, because B squared equals A squared minus C squared, so B squared equals 9. And here's our standard elliptic equation. Here's the second question. A vertex of the known ellipse is A, and the focus is on the x-axis. If the distance from the right focus to the straight line, x minus y plus 2 times the square root of 2 equals 0, is 3. The elliptic equation is, according to elliptic equation, it can be said as x squared over a squared plus y squared equals 1. The right focus is F. And set by question this, we can easily get that a squared equals 3. So our standard elliptic equation is x squared over 3 plus y squared equals 1. And there are the answers.
Hello everyone, this is Jasmine. Today I'm going to talk about Chapter 2, Conic Curve Hyperbolic. Look at the first part, the basic knowledge summary. Number 1, definition of hyperbolic curve. The first definition is the plane with two fixed f1, f2 distance between the absolute value of the difference is equal to 2a less than the value of f1, f2. The point of the track, that point set 2a equals the value of f1, f2 are two rays, and 2a greater than the value of f1, f2, no track. No absolute value of the outside is half of the hyperbolic, left or right for the right branch, and upper and lower for the next branch, and so on. Okay, now look at the second definition. It's the ratio of the distance between a fixed point F and a fixed line. It's the trajectory E greater than 1 of the constant point of the constant. Point set P multiply the value of Pf1 over d1 equal to E, which is greater than 1, also equal to P multiply the value of Pf2 over d2 equal to E, which is also greater than 1. They are equal to A, more than produce the whole hyperbola. Look at part 2, the standard equation and geometric properties of hyperbolic curves. There are two equations: x squared over a squared minus y squared over b squared equal to 1, and y squared over a squared minus x squared over b squared equal to 1. There are two graphics, and look at the focus. F1 is minus C0, F2 is C0, and another one, F1 is 0 minus C, F2 is 0C. But they have the same focus length. The value of F1, F2 equal to 2C, and A squared plus B squared equal to C squared. They also have the same range. The value of x greater and equal than A, and the value of y is equal to and also greater than A. They also have the same symmetry about x-axis, y-axis, and origin symmetry. Let's continue with nature. For vertex, line, and asymptotic line, they look the same, but actually they are totally different. We need to pay more attention on that because they are very easy to mix up. But as for axes, they are the same. Real axis length 2a and imaginary axis length 2b. This is quite easy to remember. Look at focal radius for equation 1, P on the right branch, R1 equal to the value of PF1 equal to EX plus A, R2 equal to the value of PF2 equal to EX minus A, and P on the left branch and for equation 2 are as shown. And in the last part, we need to pay more attention on centrifugal rate, which is E equal to C over A.
Here is the classwork of hyperbolic. Question 1. The center of the hyperbolic C is at the origin, and one of its focus is F1, negative 3, 0. An asymptote equation is the square root of 5x minus 2y equals 0. The hyperbolic equation is: first, we set C as x squared over a squared minus y squared over b squared equals 1. Then we can set equation a squared plus b squared equals 9. b over a equals the square root of 5 over 2. Then we can easily get that a squared equals 4, b squared equals 5. So here's our standard equation. Here's the second question. If the hyperbolic C has the same focus as the ellipse, x squared over 8 plus y squared over 4 equals 1. Line y equals the square root of 3x is an asymptote equation. The hyperbolic equation C is: first, we set C as x squared over a squared minus y squared over b squared equals 1, a greater than 0, b greater than 0. From the ellipse equation, we can know that the two focal points are negative 2, 0 and 2, 0. So C equals 2 in the hyperbolic C. And because y equals the square root of 3x is an asymptotic line of C, so b over a equals the square root of 3. We can easily get that a squared equals 1, b squared equals 3. So the standard equation is: x squared minus y squared over 3 equals 1. Here are the answers. Thanks for watching.